So we have a question in the comments of what is an op amp?
So
Which
op
is,
amp stands for operational amplifier.
yeah.
So it's used for amplifying a signal or a voltage or I don't know what. Here's the thing. I've only used op amps a little bit, but I make a lot of them. So so I'll let you go into the technical details.
Yeah, I would say that like the another reason that op amps are kind of cool is that they can do more than just amplify. So yeah, hopefully we'll see what our time is. Although we're doing pretty good on time. Wow, got that soldered under an hour. Dang. Nice. Thanks for giving us the head start, Robin. That was awesome. So yes, they can amplify signals, and like what do we mean by that? Well, like if you think about the volume knob on an old stereo, the volume knob is actually just a variable resistor, and that is hooked up like to your audio signal and also to something like this op amp. And so it actually makes your audio signal grow and shrink as you twist that knob. And so that's what we mean when we're talking about amplifying. And so and then your amplitude of your audio signal is what correlates to volume. So they can do a bunch of stuff like that. And there were a lot of old sensors, old analog sensors, although they weren't old when I started into electronics. It was like the way things worked. that basically they changed resistance with respect to some sort of input. So some things change resistance when the temperature changes. Some things change resistance when pressure changes. And so you basically took these little, resistor bridges, and what you could do is you could power them, and then you could see a tiny difference in signal that was made by that resistance change, and then you would put them through this amplifier so that you would be able to like look at the range that you wanted to and be able to get a lot better resolution in that range. So instead of just being able to differentiate like, I don't know, like boiling and freezing, right? If you then amplified that signal, then you could be like, oh, this is, 75 degrees and this is 80 degrees, that kind of thing. So amplifiers were used a lot in instrumentation, and there are like specific kinds of amplifiers that are made of usually like maybe 3 op amps that are called instrumentation amps. That are used for that kind of signal processing. And now I think it's like pretty much all sensors are now digital. So they just like spit out a bunch of ones and zeros that correlate to your temperature or your pressure or whatever, but they still have all of this stuff internally in their ICs. So it's still like definitely useful to understand how they work. Another cool thing that they can do that's like not amplification is they can be used to compare two signals. So like, is this signal bigger than the other one? And if the answer is yes, then I output like 5 volts. If the answer is no, then I output 0 volts. So it was a very early way of kind of creating something that was digital signal friendly, that was only either at 0 volts or 5 volts, that a little processor or computer could actually read and do something with, versus having this signal that like changed like kind of in infinite increments between 0 and 5 volts. And I think that A to B converters are like, so converting an analog signal that has like a bunch of that has basically infinite variation between 0 and 5 volts, converting that to a digital signal that a microprocessor can like understand and store and read. I mean, I think that that's still done with like capacitors and op amps. And, it's like, okay, is this signal, bigger than 2.5 volts? Yes. Okay. Then we'll see if it's bigger than like 3.75 volts. Yes. Okay. Then we'll go. And so there's like this successive, that's how like SAR, ADC, A to D converters work, a successive approximation. I forget what the R means, but that's okay. But so that's an interesting use of op amps too, to be, and that's called a comparator because they're just comparing two things. And then you can also use them to, not necessarily amplify, but like offset a signal. So if you have a signal that's, let's say, an audio signal that's like going through ground, it's like varying between positive and negative voltage, but you need to interface that to something that needs to read a signal that's like between 0 and 5 volts, and it can't really see anything below 0 volts. Then you can like use an op amp to offset that signal. So now it's going between like 0 and 5 volts instead of, positive, 2.5 and negative 2.5 volts, let's say. So like, yeah, useful in a lot of signal processing kind of things.
So one of our first set of kits that we made were for interactive LED projects. And we made one that was entirely analog. So it was, and resistors and capacitors. And it would create a damped oscillation. So when you got a signal that changed a value from your photo transistor, then it would trigger the oscillation, which would then dampen out. But it will also send a signal to its neighbor, who would get a smaller signal and would also oscillate, but at a lower amount. So it was sort of a networked analog computer that would just sort of ripple in the amount of light that it had. It was a lot of fun, but occasionally people would say things like, "Would you please make sure that the chips are programmed?" And it was like, well, these are just op amps.